Solve by completing the square 2x squared minus 12x plus 1 equals 0. There's something different from this equation compared to the other ones that we have. Specifically, this one has a leading coefficient on the x squared. And we haven't completed the square before when there's a leading coefficient, so we need to get rid of this. And the way that we're going to get rid of it is dividing both sides by 2. If we divide both sides by that leading coefficient, that will change the leading coefficient to 1, and then we'll be in a better situation to complete the square. When we divide these terms by 2, we're left with x squared minus 6x plus 1/2 on the left. And on the right, 0 divided by 2 is just 0. So we have x squared minus 6x plus 1/2 equals 0. Now remember, we also wanted to move the constant term to the right-hand side so that it was out of the way. So we're going to next subtract 1/2 from both sides. This leaves the x squared minus 6x alone on the left-hand side and gives us negative 1/2 on the right. And now that we have the x squared minus 6x alone, we're ready to complete the square. To do this, we take the coefficient on x, which is negative 6. We divide it by 2 to get negative 3. And when we square that, we end up with positive 9. So to complete the square, we need to add 9 to both sides of the equation. Now on the left-hand side, we have a perfect square trinomial, so we can factor it. And when we factor it, we end up with x minus 3 squared. On the right, we need to add negative 1/2 plus 9. And I'm going to do that off to the side, just so that it doesn't get too crowded in the problem itself. Now, if we want to add negative 1/2 plus 9, we can change 9 into a fraction by putting it over 1. And then to add two fractions, we're going to need a common denominator, which in this case is 2. Negative 1/2 is going to stay negative 1/2, but for the second fraction, the denominator of 1 was multiplied by 2 to become 2. So the numerator will also need to be multiplied by 2. 9 times 2 gives us 18. So 9 over 1 becomes 18 halves. And negative 1/2 plus 18 halves gives us 17 halves, which is what we end up with on the right-hand side. So after doing all of that arithmetic, we have x minus 3 squared equals 17 halves. And we can now apply the square root property. When we take the square root of the left-hand side, we have x minus 3. On the right-hand side, when we apply the square root property, we end up with plus or minus the square root of 17 halves. Now, to get x alone, we need to get rid of that 3. We can do that by adding 3 to both sides. This gives us x equals 3 plus or minus the square root of 17 halves. And we're not able to leave our answer like this because we know that we're not allowed to have a fraction underneath the radical. So we're going to have to rationalize the denominator. To do that, we need to multiply the top and bottom by the same quantity. And in this case, that quantity is the square root of 2. When we do out the multiplications, in the numerator, the square root of 17 times the square root of 2 is the square root of 34. And in the denominator, the square root of 2 times the square root of 2 gives us the square root of 4, but the square root of 4 is just 2. So now we have rationalized the denominator. There's no radicals in the denominator or fractions inside of radicals. So this is our final answer. X equals 3 plus or minus the square root of 34 over 2.